Hey, and welcome to Pomodoro Joe for Wednesday, the 13th of September, 2023. All right, today we're doing the LeetCode problem. Whoa, upgrade to dynamic layout. Sweet. All right, we're doing LeetCode problem 135, candy. This is a hard problem. So, there are n children standing in a line, and each child is assigned a rating value given in the integer array ratings. Let's have this array of ratings for our kids. You are giving candies to these children, subjected to the following requirements. Number one, each child must have at least one candy. I gotta be nice to the kids, right? And number two, children with a higher rating get more candies than their neighbors. Return the minimum number of candies you need to have to distribute the candies to the children. All right, so let's see. We have an example here. 1, 0, and 2. So our kids are rated 1, 0, and 2. That middle kid is just a bum. We give candies to 1, but we have to give candies to all of them. So candies for this first kid at index 0, they need to get 2 because candies for this guy are 1, and that means this guy needs 2 as well. So that's 5. 2, 1, and 2. 5. All right. Next, we have 1, 2, and 2. So the first guy gets 1. Second guy has to get 2 because they need to get more than this first guy. So that's 1, 2. And the second guy, let's see, they're equal, but it just says it has to have a higher rating. So this guy can get 1 as well. So that's 1, 2, and 1, which is 4. Okay, all right. So let's put 25 minutes on the Pomodoro timer and we will get started. All right, so for this one, I think I will keep an array of the candies that we're giving to each kid. So let's start with that, like candies for a kid. Candy for a kid, or kids? I'll do kid. So candy for kid, and every kid gets at least one candy. So we'll start with 1, and we'll multiply this by the length of our ratings. Cool, so now every kid gets 1 candy. Now at the end, we'll return a sum of all the candies for the kids. So sum of candy for kids. Cool. So now we have to go through and sort of figure out, well, how much candy does each kid get? Now the candy that each kid gets kind of depends on the candies that the neighboring kids get. But it depends on both the left neighbor and the right neighbor. So we might need to be updating left and right at the same time. So rather than try to balance coordinating left and right neighbors, let's just go through front to back or left to right. Let's just make sure that all of our kids have, I guess, more candies or the same number. We'll just make sure that all of our kids have the right number of candies compared to their left neighbor. So if I'm just looking at my left neighbor, am I supposed to get more candy than that left neighbor? Then give me more candy. So we're just going to go left to right. So let's do this. We'll have to have 2 passes. So pass 1. Left to right. All right. So for every kid or index in range, we're going to go from, let's see, we're going to be comparing ourselves to the previous kid. So we'll start at index 1 because we don't have anything for index 0. And we'll go up to some max index here. Let's see, I don't have that. So let's get our max index. And our max index is just the length of our ratings minus 1. Okay, so for every index in a range from 1 to our maximum index, let's take a look at this kid's rating and compare it to his left neighbor's rating. So if this kid, or the ratings for this kid, let's see, we only care if they're greater than. If this kid has a greater rating than the left neighbor, so that's going to be rating for I minus 1. That means that this kid deserves more candy than the kid at index I minus 1. So let's say candy for a kid at this index, that has to be equal to the candy for kid at the previous index plus 1. All right, so now we just go through and make sure that every kid has at least the right number of candies compared to his left neighbor. If he's supposed to have more candies than his left neighbor, then we'll take whatever that left neighbor had and we'll just add 1 more piece of candy to it. Okay, so now we've gone through and we've made sure that all of our kids have the right number of candies compared to their left neighbor. Now let's go the other way. We'll go from right to left, and we'll make sure that all the kids have the right number of candies compared to their right neighbor. So this will be pass 2. Okay, and again, we can just go for I in range, and now we're going backwards. So in that case, we have to go from the max index, but we actually go from the max index -1 because we're going to be comparing it to a neighbor to the right, in our case, index +1. So the very first one we have to look at is the max index -1. And we need to go down to -1 because, again, with ranges, they're not inclusive. So this will actually take us to and including 0, but not beyond. And we want to go by steps of -1. All right. So now let's compare this kid to the kid to their right. So if the rating for this kid is greater than the kid to their right, well, then this kid should have more candy than the kid to their right. Now, we might already have more candy. So we did start out initially with 1 candy for everybody, but we went through and we added more candy compared to our left neighbor. So this kid might already have more candy than its right neighbor. So let's check that here. So if they're supposed to have more candy, but they don't, so and candy for a kid, index I is less than or equal to candy for a kid, index I +1. So in that case, we have less candy than we're supposed to have compared to our right neighbor. So let's give ourselves some more candy. We'll give this kid some more candy. So candy for a kid at this index has to be equal to candy for kid at the right index, I +1, +1. So now we've made sure that our kids have the right number of candies compared to their left neighbor and the right number of candies compared to their right neighbor. Now you might be thinking, well, if we messed with our right neighbors, that could mess up our left neighbors. But you remember, we were just adding candies. We know we have to have more candy than our left neighbor here. Now, if we're going through and we need to have more candies than our right neighbor, then by adding more candies to ourselves, we'll already have more candy than our left neighbor. So we'll just end up with doubly more candy? I don't know. All right, so we do 2 passes, and I think this is it. Let's check it out. I got something wrong. No, it's not ragings, it's ratings. Poor raging children, because they're not getting their candy. All right, we almost pass. What are we missing? Let's see. We only got 4 on this guy. So let's see. Let's check this out. I think this is good. We are going from left all the way to the end. Oh, this is the problem. We went 2, but not including max index. We have to go to max index +1. There we go. Let's submit to see how we do. And we pass. We do all right. We beat, 83% for runtime and 99% for memory. What? All right, well, I'm pretty happy with that. I don't think I'm gonna touch it. All right, so this has been LeetCode 13.5, or in other words, 135, candy. Candy, 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 candy. This was a hard problem. So for this, we just did 2 passes. We went through comparing ourselves to the kid to the left, and then we went through and compared ourselves to the kid to the right, made sure that we had the right number of candies by comparison, and we summed all the candies at the end. Cool. All this talk of candy is making me hungry. I think I'm gonna go. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.